Wearable Thermo-Element. Wearable devices like fitness trackers and smartwatches look like the biggest thing in technology since the smartphone. But ask anyone who uses them and they'll say there's one big problem: short battery life. Imagine you could power your devices while wearing them instead of the hassle of plugging them into yet another charger. After 30 years as a device engineer, Byung-Yin Cho took on that challenge. His research team at KIST came up with a game-changing thermoelectric generator based on glass fiber. The solution uses body heat to power devices even in the wearer's sleep. Its thin, flexible design can fit any shape and could even be woven into clothing. Professor Shou believes wearable devices are just a stepping stone towards implanted electronics, with uses like health monitoring for an aging population or secure payment as a replacement for ID cards. But how could we keep them charged? Now the solution could be within our power.
I see Joël de Ronet smiling in the audience, probably thinking, I thought of that 30 years ago. Professor Cho, I mean, turning heat into power is basically what any power plant will do, except you're turning not that much heat, which is like skin heat, which is, well, pretty much the temperature in this room, into usable power. How do you do that?
Actually, the power generated is depending on the temperature difference.
So if I have a fever, I can power my smartphone.
Yes, maybe in the cold weather like today, we will be able to have more power. But anyway, in general case, in our usual situation, we have a temperature difference around 5 degrees C between the body temperature and the surrounding area. So with that temperature difference, our device can operate a small activity tracker like this. This one can measure our step counter. I mean also communicate with my mobile phone. So this one we can make it a self-powered the device. So that means we don't need the charge. And also for the smartwatch, we can cover not 100% at this moment, but we can cover some percent. We are targeting around 20–30% of the smartwatch at this moment. But what we expect is our technology will be developed further as time goes, and at the same time, in the other side, electronics will consume less power, because a lot of people now are doing the research on the low power circuit. So eventually, the low power trend and low power consumption trend and the more power generation from our device will be merged in the future. So then means later we can cover more and more power for smart watch or some other wearable devices.
It's funny because we have all been waiting for batteries to get better. And when I say better, I mean way better. The state of batteries today is just absolutely frustrating, especially when you compare it to how innovation works in the rest of the digital realm. We have machines that go, I mean, my tablet here has 4 times the resolution of the HD TV I bought 3 years ago. So this is how fast it goes. Batteries don't go that fast. Batteries don't get better this fast.
Yes.
So you sort of took a shortcut. How long until that can be used to power something more than a bracelet, like maybe a smartphone?
Actually, I launched a startup company last year, September last year. And we are targeting to release our engineering sample in the first half of this year. And now we are talking to many electronics companies.
Well, you're in Korea, I mean...
Korea and US and many others from the different...
I have a few ideas about who must be coming knocking at your door.
Yes.
Like, hello, we do smartphones, can we be friends?
So, so actually we are, our company is targeting to start the production sometime next year.